like this is a chance to interact with the other people at the conference, make new friends, and see old friends. And we have provided a couple of opportunities to help you do that. The first one is this evening. It's the major conference reception, and it's also a buffet-style dinner. It's going to be at the Pacific Science Center, which is at the Seattle Center, which is the site of the 1962 World's Fair. It's about a little over a mile to the north of here. We've arranged some interesting transportation via the monorail. The monorail will begin running at 6:30 for free for any of the people in the conference. Your name tag is your ticket onto the monorail, and you can spend the whole evening, if you'd like, just riding it back and forth. Or when you get to the other end, you could walk from there over to the Science Center. And in fact, it's that walk that motivated us to get these umbrellas, because we thought there's a pretty good chance it may rain in November in Seattle. It should be fairly easy to find the monorail. It starts at the Westlake Mall, the top floor of the Westlake Mall. If you go out the exit on Fifth Avenue, you'll see the monorail running right down the middle of Fifth Avenue, and you just follow it a block or so to the south to Westlake Mall, and then you can take the escalator to the top floor. The top floor of the Westlake Mall also is a place where there's lots of fast food if you're looking for something quick for lunch. Tomorrow, Tuesday, in the afternoon, there will be demos, and the demos will start at 4 and run continuously till 8. In addition, there will be a SIG group business meeting occurring in one half of this ballroom. So those people who are interested in the business meeting can do that first and then go join the demos, and other people are welcome to just spend the whole 4 hours at the demo. To make the demos especially interesting, we've added a reception. This time it's not dinner, but hors d'oeuvres, appetizers, that starts at 6 and will run from 6 to 8. So we'll hope you'll take advantage of that as well. Finally, I'd like to introduce Saul Greenberg, who in turn will introduce our plenary speaker.
Good morning. My name is, are we on? Here, I'm on this little guy here with technology. How are you doing? So good morning. My name is Saul Greenberg, and I have the honor of introducing Doug Engelbart, the recipient of the 1997 ACM Turing Award. As part of this award, recipients are asked to present a Turing Award lecture at the ACM conference of their choice. And we are fortunate indeed that Doug has chosen the CSCW conference to do this lecture. Now, while most of you are familiar with some parts of Doug Engelbart's work, I'd like to spend a few minutes reviewing some highlights with you. The time is the very early 1950s. I hadn't even been born yet. Doug had just become engaged and was, from what I understand, extremely happy. And he realized that he had achieved all of his personal goals, but he had not yet articulated his work goals. He thought very hard about what problems were worth solving in terms of its benefit to mankind. To paraphrase, he came up with the following problem statement that you see here. And he thought that the world is getting more complex and problems are getting more urgent. These must be dealt with collectively. However, human abilities to deal collectively with complex, urgent problems are not increasing as fast as the problems are. If you could do something to improve human capabilities to deal with these problems, then you'd really contribute something basic. Well, while thinking about this, it suddenly flashed on him that this vision came up that, again, paraphrasing from an interview that he had previously done, where I had the image of sitting at a big CRT screen with all kinds of symbols, new and different symbols, not restricted to our old ones. The computer could be manipulated, and you could be operating all kinds of things to drive the computer. And this is really interesting over here. He also thought that I also had a clear picture that one's colleagues could be sitting in other rooms with similar workstations tied to the same computer complex, and could be sharing and working and collaborating very closely. And also the assumption that there'd be lots of new skills, new ways of thinking that would evolve. Now we have to remember that during this time, transistors had just been invented. computers were huge number crunchers, far too expensive to ever consider for single people to use, let alone the collective use that we're describing here. Often these devices had a mean failure times in terms of minutes. So this was indeed a vision of the future. To prepare himself for tackling this problem, he trained himself in graduate school, eventually joining the Stanford Research Institute. In 1962, he described in his landmark paper his conceptual framework for augmenting human intellect, a framework that brings his vision out formally. And again, quoting from his report, he wrote, "By augmenting human intellect, we mean increasing the capability of a man to approach a complex problem situation, gain comprehension to suit his particular needs, and to derive solutions to problems." And as part of this, that one objective is to develop new techniques, procedures, and systems that will better adapt people's basic information handling capabilities to the needs, problems, and progress of society. Over the next 6 years, he created a team, acquired funding, and started implementing this vision. Along the way, he and his group invented the mouse, but as we will see, this is only a very small part of his complete project and vision. This phase of his work peaked in 1968, where he took a huge risk by deciding to present his ideas and the developing NLS system in a live demonstration at the AFIP Fall Joint Computer Conference. Now, many concepts that you'll find familiar in today's interfaces were first introduced and were first implemented in the NLS system and shown in this presentation. And just to touch upon a few of them, in terms of document processing, at this presentation, he showed ideas that you see in modern word processing, the idea of outline processing, the ideas of hypertext, hypermedia, and of collaborative hypermedia systems. In terms of input and output, you of course know about the mouse, but as well he had a one-handed corded keyboard so that you could use the two at the same time and not have to switch from one device to the other. He had, certainly by those day standards, very high resolution displays, as well as multiple windows so people can compare information at the same time. He also designed furniture especially for the office and computer user. Now, especially important to CSCW are his notions of shared work that he demonstrated there. Ideas such as shared files and hypertext systems. The ideas of being able to personally annotate any part of that structure. Electronic messaging so people can convey information to one another. Shared displays so people could work together at the same time, including multiple pointers so people could gesture over the surface. Audio and video conferencing to support the basic communication acts. And as well, he had formed very early ideas of the internet. Now, what I'd like to do is show you a 6-minute extract from this presentation. Now, this was an hour-and-a-half presentation, so you're only going to see a touch of the things that he presented there. So here's the scene. On stage was Doug Engelbart at the control of an online computer display whose output was projected onto a very large screen. Behind the scenes, Bill English and the crew managed cameras and signal switchers connecting the conference center with the Menlo Park lab 30 miles away. If we can roll the video, please.
Started that way, and we never did change it. So I'm putting in an entity called a statement, and that's full of other entities called words. And if I make some mistakes, I can back up a little bit. So I have a statement with some entities' words, and I can do some operations on these. I can copy a word, I can get a bit of material there. And there are other entities like text. Say after there, I'd like to copy from that entity point to that point, and it'll copy it. So here's what I drew with a picture drawing capability here. It's a slide map if I start from work, and here's the route I seem to have to go to pick up all the materials. And that's my plan for getting home tonight. But if I want to, I can say, the library, what am I supposed to pick up there? I can just point to that, and oh, I see, overdue books and all. Well, there was a statement there with that name on it. Go back. What am I supposed to pick up at the drugstore? I see, interesting. All right. If I want to send Bill English, WKE, a message, I would put that in the file, WKE, DCE, with that pound sign in between. So any statement that's marked like that means there's a message to him from me. If I want to, I can say was also for Dave Evans, like that. So that's from me to both of them. Here's a little expression in a special language that means I'm going to look for Mr. XXX, a message from him. All right, what if I say I want that XXX to be DCE? That says someplace in there I want to find that pound sign and DCE. So we've got a little compiler. We say from there, compile it. Comes back and says, I did it okay. And now I can say, all right, only show me the statements that passed the test, that someplace in them they have that string. There they are. So in every one of those, that's from DCE, DCE. So I'm going to establish a collaborative mode between me and another terminal. Bill Paxton's at a terminal back at SRI. So Bill, will you come in through this intercom?
Hello, Doug.
Hi. I'd like to have him see my text. And so this special thing, if I label 13, will switch over. So in his display, he sees my text. So I'll execute it. And sure enough, it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting there in Menlo Park looking at this text, and he can point to it. But we've carefully reserved for me the right to control and operate on this. So my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So we've set up now audio coupling, and we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point, and maybe later I could hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now, and add another feature that hardware-wise is available to the kind of display we have. I'd like to see you while I'm working on it. So before I can do that, I have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine. Hi, Bill. That's great. Now we're connected audio. You can see my work. You can point at it. I can see your face, and we can talk. So let's do some collaborating. You're going to have to defend that.
Going to give it to me?
Yep.
Oh, okay. We've been talking about retrieval all afternoon, really.
In that network, we're going to try to develop a special service to provide network information, relevant network information for people, for the kind of information that it takes to operate such a network. Who's got what services, what protocol do I use to get there, who's up to date, how much, where's the user's guide, where can I find the paper that describes this system that so-and-so offers. That's going to be a very interesting challenge for us to utilize our tools for organizing and retrieving information.
In 1968, I think I was 14 years old then. I didn't know what a computer was, except that it was this funny thing with cards and paper tape, and I kind of heard about this thing called a teletype. The 1970s and 1980s were kind of interesting, because while many people were inspired by Doug Engelbart's presentation, people, in fact, who went off, and part of his crew went off to Xerox PARC and other places, he was definitely too far ahead of his time. Over the next 20 years, he saw fragments of his ideas incorporated into interfaces, but without the vision that could have made these ideas truly powerful. For example, we saw the production that we still have today of standalone applications versus the idea of a completely integrated environment that he had demonstrated. We saw an emphasis on ease of use versus the idea of trying to augment highly trained workers to do very, very complex problems. We saw the ideas of office automation, and again, versus the idea of bootstrapping, a co-evolution of new tools and new ways of thinking. And of course, we saw almost complete emphasis on the single user versus the idea of collaborative work, which is so essential to the idea of cooperative problem solving. In recent years, we as a community have just begun to catch up with Doug Engelbart's ideas that he is still pursuing at his Bootstrap Institute. The significance of his contributions and visions are finally being recognized. In 1986, and I think we as the CSCW community can be proud of this, Irene Greif, in her book, in the first book of CSCW readings, included 3 articles by Doug Engelbart to lay the foundations to our entire field. In 1997, just last year, he was the winner of the prestigious Lemelson MIT Prize, a prize that comes with a $500,000 cash award, which I'm told goes mostly to the tax man. In 1998, this year, he was an inductee to the National Inventors Hall of Fame. Later this year, on December 9th, Stanford University is going to reconsider his work in an all-day symposium titled Engelbart's Unfinished Revolution. And of course, you all know that he's the winner of the 1997 ACM Turing Award, considered the equivalent of the Nobel Prize for computer science in our area. As already mentioned, we are indeed fortunate that he is presenting his ACM Turing Award lecture to us today. Well, ladies and gentlemen, I'd like to introduce Doug Engelbart.
You know, it's a funny thing. Seeing those things, it takes me back, and it's a little bit hard to sort of fit that past history with today. And you know, I stand in front of you, and it's very hard to feel like I'm a hero. It's more like, well, one of the things I worry about is people saying, "Oh, you're an historical figure. You belong up on the shelf." And it's sort of like if Benjamin Franklin showed up and you think you applaud him a great deal for doing that lightning kite deal, but you know, that's where you belong on the shelf because we've moved on since then. So, what you know, there are a lot of things in the 70s and 80s that moved ahead with experiences that we lost the research money because it was, you know, the world then was thinking of office automation and not augmentation. And many of the things we did just, you know, honestly seemed wrong to enough people so that the only way we could keep our system alive was to go out into the commercial world with it. So we got SRI to auction the system off, and a timeshare company in Cupertino, California, that's no longer alive, bought it. So I went with the group to keep the system alive because there was a lot into it. And I didn't have a very active part in its manipulation because I was viewed with considerable and maybe justified suspicion by the managers of the commercial world in there. In 1984, this company was bought out by McDonnell Douglas, who was making a big push into the information systems service world and acquiring a bunch of companies to create about $1 billion a year business, which subsequently they folded because it sort of didn't work out for them. But what this did was allow me to go inside McDonnell Douglas in the heavy knowledge work domain and do a lot of interaction with them about, you know, how this sort of approach could actually really be an integrated environment for very complex problems of designing and building and field support for products as complex as an aircraft. And so it was a great learning experience for me, and we couldn't make it happen in there, but it was a great experience, and you know, painful, but I wouldn't have missed it. So anyway, in 1989, the picture I'd gotten by then was that if the scale of need for being able to really cope with these very large, complex problems and issues was something that was going to take cooperation among a lot of different organizations, especially the end-user organizations that had to get proactive in this environment. So it just seemed like one thing potential was to get some kind of consortium going among end-user organizations to sort of work their way through. And the concept by then was pretty clear that unless there was something you could call an open hyperdocument system that prevailed, it wasn't going to be able to justify or meet the potential at all. And so one of my daughters who'd been working in this area quite a bit, Christina, and I set up this Bootstrap Institute with the whole purpose of raising a flag to say, hey world, this can be an important thing, and we're trying to organize a kind of a consortia approach for that. So slowly ups and downs, this has evolved until a year and a half ago, a group, almost 2 years, formed the Bootstrap Alliance. So the Alliance is the framework for this consortium that's going to do it. So anyway, that brings you sort of up to date a little bit with the history. And I really, I appreciate very much Saul's glorified introduction, but there are a few things in there that aren't true. And then some of the things are that I just have to tell everybody that I'm not a very good doer, organizer, designer. I keep wandering around. I'm a very intuitive guy, and so I can make leaps, etc., like that. But if it weren't for the people, like Bill English and Jeff Rulison and Bill Duvall and Charles Irby and a whole crew of guys that could really do things, that none of that would have got off the ground at all. So, and it's still the case. So I need to find people that can do things to help me go there. So one of the things I'd like to do today is end up challenging you guys. So anyway, let's get on with this. As you got the big thing about behind a lot of this is saying the potential, the way the technology is evolving is something that is accelerating greatly, and that our organizations are only accommodating it with funny little steps, and we're way off in what we really need to pursue in that. So that is an underlying assumption in there that we could study, and it would take a lot of interaction to get that into details. So anyway, with that kind of explosion, there comes a little problem of very large problems in the. If I seem to be fumbling around, I'm looking for my watch, so I have a chance of getting through this thing without getting stuck on telling you stories about the good old days. You have to watch these old men. So anyway, without belaboring it, there just really are the same technologies that are going to be able to do great things are also going to cause great problems. And so one of the issues about saying that there's a lot of that to concern ourselves with. And so the thing that was brought out in there that, yes, then there are opportunities, and a big one here is that that one could really assume that we can boost our capacity for effective collective action. So that has been the dominant thing all these years pursuing this, and I think it's something that that the CSCW folks are sort of about the central ones I know that are floating and going away at that goal, but I feel like it needs more. There's more need and more potential than the world is recognizing. And one of the other big things that comes along with this is that's a dual thing that's been in my head since the early 60s, is not only can you augment our capabilities, but that there's a real potential for being able to augment our improvement infrastructure at the same time by judiciously applying that. And so that's what I'd really like to bring out in the ensuing discussion today, and then point out how you guys fit into that improvement infrastructure and what you could do about it. And if I make you feel appropriately guilty, it's probably by design. So don't worry about it. just go fix the world up. So these are the sort of 5 kind of major issues in here that I'll deal with. And the first one is called the coevolutionary frontier. And this is just very, very basic back there in the 60s that I looked at this and said, well, we know that people have basic genetic human capabilities, and with just those alone, we're totally helpless. So we say, yes, the engineers look around and saying, oh, there are all these neat things we can build and apply in there, which I just started labeling a tool system. And I started going down there with all the computer neat things I could do in the 61. And then I got to realizing, oh, there are a few other things too, you know, the way people look at the world. And, procedures that they're going to work on, et cetera, like that. Oh, yeah, customs and things. These are likely to be important too. And, oh, language, wow, that's where I really took off on. And knowledge, oh, yeah, of course. And, oh, boy, pretty soon you begin to realize, all right, so I couldn't find anybody who could tell me the name of that collection of things, so we just started calling it the human system. And it's more than just culture or society, it's just a whole mix of that, at least in my terms, recognizing. So this became, for me, something that just dominated my thinking ever since. And it's really, really important. And I'd done a very detailed, deep study in the late 50s on dimensional scaling of electronic components, realizing that unless they could get smaller and faster and cheaper, the world wasn't going to get to where I wanted to go. But after I'd done that enough, and I learned some very interesting basic things about scaling. And one of them is that if you change the scale of some of the key parameters in any complex environment, it changes the way the environment works. But after a given point, it changes it qualitatively in very surprising ways if you're not oriented about that scale change. So this was just very true that as our electronic components get smaller and smaller, we're going to have to give up semiconductor, because the way that different surfaces and volumes and so on like that interact as they change. And you say, okay, but there are a lot of other phenomena that are going to be harnessable down there. You know, things can cool up and warm up and cool down in nanoseconds if you get them small enough, no problem. So you could even make something whose bistable thermal condition, that if doesn't sound very practical, but just as an example. So anyway, the scale of change that is really going to come about in this right-hand column means that there's no way in the world that left side's going to stay the same and be able to harness it. So you say, okay, anything that's going to emerge from there about new transportation, even teams, people working together, they have that same business of the combination of those two, and especially any kind of people organization trying to work together like that. So this is something that evolved later, is saying, oh, if you could actually deploy some of those technology things along the axis here, and what you really have to realize is that this particular chart could probably only be done for a few, one or more sets of capabilities, is what you're really trying to talk about in there. And that the human system development, or sort of, if you think about them as orthogonal axes, and you think about, oh, as society got started, yeah, if we, far back as we know, none of them was ever without any kind of artifacts, and everybody we seem to have language from way, way, way back in the human race like that. So that there were progressions as more things go. And one of the big progressions was when people transformed from a hunter-gatherer to agriculture. And so one of the real things I pick on that one is because trying to think of some of the things where there was a really very large shift in the human system side as they integrated these new ways of technology, et cetera. So moving to agriculture just changed just immense amount about their social structure, social interaction. They started having dwellings and different tools and different social structures and all of it. It's just a huge change. So I'd been trying to go back to think about when was there a similar scale of change hitting society by new technologies? And I have to go clear back to that to think of something that, in my mind, had the qualitative scale of impact on the social human system side that I think this technology that's emerging now is going to have on ours. You know, the printing press was a blip by comparison, or the Industrial Revolution was significant, but nothing by comparison. So it's this difference in what people think about as society. Different societies, different organizations evolved out here in different places, so you find that there's a distribution. So, okay, pick your favorite organization that you do and say, I bet you think that's where you are today. Say, yes, we could get better on both of those cases, but we're right out there. Well, if somebody knew how to make this distribution and do analyses, I'd really like to see about that, because I sort of feel like, okay, this is one picture which people had evolved for a long time, and that slow evolution of our society, sort of, the frontier was not very far away, and most people sort of just, it accidentally happened to them. Something new would come on the market, and they'd start adopting it and watching other people, so the evolution was slow. So then we say, oh, what if this were the scale? So, all right, I think this one of the things I can do without is just take a look here. Is 1964. You know, Saul was showing the pictures about what we did and how far off it was, but look, for us to have a display to test out anything, including checking out the mouse, etc., we had to build our own display because you couldn't buy a computer display. And so you say, was that big box then was the whole thing? No, that big box was just the electronics that moved the beam around, because to get that big a tube, you had to have high voltage beam like that, and to move it around like that, it's very different from sweeping in there. So you had to have a lot of power for big things. Oh, well, what did the writing and stuff? Oh, this cabinet behind her, full of vacuum tubes and such, was all the thing that did the character generation. So that whole thing in there is what it took for the computer to send ASCII signals there to say, you know, go to this location, write this letter, or move it, or draw vectors. And the cost in 1964 dollars was around $80,000 to custom make that, to do the experiment. So if we took the cost of living index and multiply it like that, it would be some hundreds of thousands of dollars equivalent now to start doing some sort of a track. So you look at that and and realize that the changes were heavy. So then we also did some things about interactive online meetings at one given time like that, and this is 1967. And so just the painful struggle to get the changes moving in there and the expense of them was sort of indicative of this. But more than that, it was something something to think about. Is just think of today that nanotechnology is something very, very real. And so I talked to Eric Drexler one time to say, you know, give me something about what I can sort of feel like. Intuition, I'm just believing on it terribly. So we got around to thinking about how much could you hold in your hand, how much computing horsepower. And and say, what, 30 years from now? So he said, okay, and guess. And as much computing capacity and memory as is contained in all of the computers in what? The whole campus? No. The whole town? No. The whole county? No. The whole state? No. Oh, the whole country? No. The whole world. See, the scale. That's what he was saying, and I believe him. So in 30 years, you say that nanotechnology is very highly likely to do that. So how long will it take the world to get ready to harness that sort of thing? And what kind of changes it will make? And there are other things we know that people talk about wearable computers and all, and I started conjecturing about surgically implanted computers. They get their energy from your metabolism and can connect directly to your nerves. So this is okay, not that it leads to a particularly pretty picture of the future, but those are the kind of things that are there inevitably, and they'll be probably within most of your lifetime. See? So this kind of comes back. Also, the intelligent agent business of it's not going to. It represents one of the potentials as one of the hazards. On one hand, whole fleets of those things are going to be out there and negotiating with each other and doing things on behalf of humans, or so the humans are going to want to hope that they're doing it on behalf of the humans. But at what point can they sort of get aberrant and start doing something on their own and organizing, and maybe we won't even know it. So talk about virus infections. It's like cancer of our whole world. So there's, on the one hand, being able to harness intelligent agents is going to be something that will take new vocabularies, new flexible skills, all kinds of processes, procedures to do it well. It is sort of, I hate to say dumb, but it's with a very limited vision that people sort of feel like as they move into the future and become effective at this knowledge work domain, that they'll do it with smart agents that are not going to make the human learn anything, because they'll do it for them. So that's just counter to the whole rest of the way the human system adapts to harness something. So anyway, this is much more my picture of what's there, but it doesn't much matter whether you're looking at the picture number 2 or this number 3 about getting ready and getting moving. And one of the basic things is that how do you explore that space? The marketplace is just not very good at helping you explore it. And if you don't believe me, well, then you just pick one of your favorite vendors and you say, can you show me how your systems are impacting our organizational effectiveness? Oh boy, you bet. Well, can I come and see? Yep. And you get there and they pull you into a demo room and Joe's going to sit down as the expert demonstrator, and you say, no, wait a minute, you didn't get what I meant. What I mean is I want to look around in your organization and see how you really do things a lot more effectively using those tools. Oh, big silence. that if they really operated like that, and if organizations who are the end user buyers started being able to do that, they said, look, if you're telling me it's going to make so much difference, show me that way. And so this isn't the way. So the end user was sort of helpless. So how is this space out there going to get explored? So we use the term outposts out there. And without doing something in the way of serious outposts, there isn't going to be anything to guide the people who have to say, I got to take my organization out there. So this is a major issue and a problem. So on the one hand, wow, there's a huge frontier to explore. On the other hand, there's this very serious challenge about how, in a complex society, do we start exploring that and moving out there in that frontier. And so this sort of gives you this coevolution frontier image. So a little bit then about what we mean by the collective intelligence, shift into that. And so we say, okay, groups of people that cluster around, and you can think of the success, individual groups as nodes on this mandala, or individual people, or organizations in the consortium. Excuse me. I was tempted to gargle. Yeah, just to show you what a sedate old man I am, huh? Anyway, so take that as a picture of people working together. And you could also generalize it to say all the members of SIG Chi or SIG group or whatever, that you're working together for some purpose. So most individuals belong to a number of different organizations of that sort. So it says if you're really going to, in the future, work together and depend on collective knowledge, you really have to have a common collective knowledge repository. And so there's where you look at it and says, the only real hope is hypermedia etc., for providing that and the mobility and maneuverability, etc., to really harness and use it and develop it. So get with more discussion, and I'd love to go into a lot of this more deeply, but I want to get on. Last Thursday I thought I was getting this bad cold, and I called up your chairman and said, I might not get there. So anyway, I got some medicine, and I'm standing here propped up that way. But highly motivated, I tell you. So anyway, this sort of an image, and this grew out of a number of things. For one, I began very, very early about making a comparison of sort of saying, any human organization, collective team, corporation, community like this or something, you can make a likeness to a organic, biological organism. So call these social organisms. And you said, well, one of the interesting things is they've evolved like other organisms have evolved in very slow and important ways. A lot of variations in their different details. But then all of a sudden, this digital technology emerges very, very suddenly in sort of evolutionary timescale. And suddenly there's a brand new nervous system for these social organisms that's just so startlingly higher power, capacity, speed, everything else than anything we have ever had before in our social organism, that you say, oh, then what, we're just going to automate a lot of our old organism's functions? No, the whole organism is going to evolve very, very radically. And that's the kind of image I just really feel is so important to try to get into the dialogue out here, is that radical evolution that's going to happen. And it's going to cause lots of problems, and it's going to need good collective smarts to be able to cope with that and get us the best out of it. So he says, what are some more of the images of this? He says, well, like any other organism, the social organism has to keep track of the external environment. So it has to get smarter about doing that. Bringing that in is what you call intelligence collection, and being much more alert about the dynamic changes which are going to be happening faster and faster in its environment. So it keeps these all there, but like any other intelligent organism, it's got to be able to assess what are the opportunities and the threats out there. And then it's got to be able to, marshal and reorganize its resources, and then pursue some new good plan and coordinate itself like a very highly well-coordinated organism. So the social organisms of the future will just be very, very different than ones that survive. And so this is like the case of saying, how do we get going in the kind of constructive evolution of our social organisms out there? Well, the current way isn't radical enough or effective enough. That's my feeling. So a big part is saying, okay, it's important to go after this collective intelligence issue because we're going to need it very badly. And another question is coming as saying, oh, if we start making headway in that, maybe we can use its improved collective smarts to be able to, among other things, more rapidly improve our collective smarts. So that's bootstrapping. So in order to kind of focus on a major set of organizational capabilities that give you this collective IQ, collective intelligence, and then we just picked out this subset that does pretty well for a bundle of things you can talk about. How do you actually improve that set of capabilities? The concurrent development, integration, and application of knowledge. And it takes quite a bit to dig down and say what those means. And you say, yes, learning is involved in that, and innovation is involved in that, and knowledge management is involved in that, et cetera, et cetera. But this is sort of a general term that we've been using now for 6-7 years that was important. So again, we could go deeply into that. So one of the things that's for sure this open hyperdocument system that there's just no way we can keep evolving, and I'll get to it more detail later. No way we can keep evolving in any kind of radical way if we don't spring loose from proprietary knowledge, the actual architecture of the containers of our knowledge just have to become an open sort of system like that, because there's just no way the evolution can occur for that. So you have to have that to facilitate all this thing for real work in there. Capture, integrate, and manage emergent heterogeneous knowledge to enhance access, maneuverability, scalable, interoperable across domains, etc. So we can get some more examples of this later, but it's the sort of thing that in the later 80s just became so clear to me that I just had to break out of industry to try to say, hey, it needs a different way. And it's one of the important messages here today that I'd like to deliver. So, okay, we've taken care of a very short little patch about collective intelligence. So we talked about the coevolution frontier and the collective intelligence as one of the very important set of capabilities to try to achieve by moving out into that frontier. And the next one we start talking about the improvement infrastructure in a way. So again, cramming a fair amount of conceptualization into a short passage. You could look at any organization, any team, any community like this one, any consortium, any government, anything like that, to say, okay, that organization's got these 3 categories of activity in there, and they've always been there. And it's just that categorizing them this way is becoming more important because things are moving so fast. So we just say activity A, and here we can be careful not to say it's A person or B person. That's, you got a hat on that says I'm doing my A kind of work right now, or B and C. So the A kind of activity is the everyday way you've been doing it, and you hire people, you train them into doing the jobs the way that they're being done, etc. Your product development is being done the way it's been done before, et cetera, et cetera. You're not invoking any new capabilities to do A, you're just using the ones you have. And it's based upon the human tool augmentation system you have. So he says, okay, when we're trying to improve the capability of our organization to do its primary work, then any activity that's there to do that improving, let's call that B. And this may turn you off to say this fussy kind of categorization, but it just turned out to be very, very useful in quite a few kinds of ways of abstraction and thinking of strategy. So I'm just going to put it in here, whether you are bored by it or bothered by it or not. So there. So B is what proves the capability to do the A work. And so there are examples of it all the time. So most of you are engaged in some kind of B. But what's C? Well, if B has to know more, have more experience, understand more in order to do the job today, then you've got to improve the B activity capability, which is C. And then maybe somebody's going to say, aha, you're leaving off D and E and F, and I say, yes, it goes right on up over the alphabet and on. But after C, they're all improving an improvement capability. So let's just take it off from, leave it at this A, B, and C for the time being. So this was kind of important for a number of things. One is I can't find any organizations that do their accounting and auditing in such a way that they can isolate what they're spending on B and C, which would be very important in the times coming, because you're not going to be able to look up and down the street at other organizations of your nature to see, hey, how are we doing? It's like you can do for product development or research in there. So if you come back into this ABCs in this frontier like that, you realize in a sense that what C is doing is scouting out the frontier and finding knowledge about it and trying to provide orientation and some experience for whoever's going to move it out. So it's the B that moves the organization out into this frontier. So it sort of gets you a clear picture in this sense that the frontier opening up so much faster, you just have to get much more energy into that scouting, finding out what's there and trying to pick out which are the good paths to go. And then the B has got to learn how to take you out there, which is going to be hard, complex, and expensive. So anyway, it's just much more. So this whole thing of frontier and outposts there are just a very important part of trying to cope with tomorrow. So there we get all done with that. So we look at something more about the improvement process. And he says, okay, look for other organizations. So here you're saying, if your organization is interested in one set of particular kind of capabilities to improve in its A, then it might go up and down the street, so to speak, and find other organizations who also have the same kind of interest in that kind of capabilities. So they're all going to be doing very similar C work, which is out there exploring that frontier and getting knowledge and experience. Well, it's pretty clear that that even though it's a competitive world, that it'd be better ahead both economically and sharing the costs of that, as well as some kind of stability that you're not missing something. You aim for a particular place in that frontier, and other people might have done modeling and scenario development to find out that that's a very dangerous thing because the next step is blocked by something you've done by getting there. So it'd be a lot of safety and cost economy in that. So he says, okay, let's consider that you can that you can do that. So the thing to do then is say, okay, let's form a C community that we're sharing a fair amount of that C kind of work. Well, it turns out then there are many improvement communities like that already existing, and many consortia are doing it. But the sort of heightened awareness of that and I have a frog in my throat. Must be the weather here, huh? So what I have to tell you, though, is I grew up near Portland, Oregon, so I'm used to this weather. And, and I got used to this particular geographical area a long time ago. My mother grew up on a homestead on a little town you probably have heard of called Redmond. And my grandfather had a dairy farm and its homestead. So when I was in the 5th grade, my father just died, and my mother moved up to, we lived with her sister on that homestead for a year. So I went to school in Redmond, Washington, way back in the middle of the Depression, in which I couldn't even find the landmarks that I thought would stay there about the terrain and the slough. Anyway, things have changed. And I think how much has changed for that innocent little country kid, too. Boy. So anyway, this kind of a C community is just very basic. So this begins to raise something about, hey, you know, there's an infrastructure that already existed, not very clear-cut or effective, that took care of the improvement of our difference of social capabilities and organizational capabilities. And this is something you say, well, you know, if everything's changing so rapidly, we really need to take a new look at the improvement infrastructure. And that's the thing that came to me so clearly in the 60s. Just, wow. So what can one research group do? Not an awful lot. So because collectively speaking, you have to change a lot of things in society. So it's going to take a different kind of infrastructure that's capable of addressing this blastingly opening frontier and do some of the exploration out there, as well as a very difficult job with lots of pragmatic blocking-like problems and trying to move people's attitudes, change their roles. You got old guys that are close to retirement and says, get all rigid and says, hey, don't go reorganizing around me. I worked for so many years to get so I could do this job, and you change it like that, and I won't be able to do it anymore, so what happens to me? So there are lots of just basic things that somehow need some pragmatic and hopefully compassionate way to deal with. We used to try to change groups in the 70s when we were doing things out there, and we found out that you almost, if you're going to try to make a fairly radical change in a test group, you better do some sort of social analyses ahead of time, because some people who seem very effective in a current way of working just go absolutely rigid when things change around them, that they're just not very malleable. And that can just destroy a whole experiment like that. So anyway, there are a lot of factors to include, and so learning how to explore and move is a complex job. So we said that, all right, we're sharing this, and the real customer for this particular activity are the different B activities. So this is one of the things that starts clearing up. Boy, if I could remember. Anyway, the sort of, it's always important to know who's the customer in this case. So it's these B activities that are trying to be given more knowledge and experience so that they can plan and implement the changes in the A, stuff like that they have to do. So it's a very thing. It's a lot of communities that are there don't get that very clear, but it just has to be done. And clarifying what are the capabilities that they've agreed are the ones that they're trying to boost in the A activities. So it's turned out through these years that the issue of capability improvement just somehow keeps gravitating right to the front for me. That a lot of things you can start talking about, but in this sense, that seemed to clarify a lot. That it's the functional capability of the A activities that can be addressed in this fashion. That this is the particular framework that we're bringing out here like that, and saying, okay, so what characterizes this particular community then, or what are the set of capabilities it's chosen to start focusing on how to give Bs better ways to go after improving those capabilities in their A. So this is a very important sort of thing strategically, both for forming these kinds of alliances and for then strategically deciding on what kind of improvement processes would you like to focus on first. So then we say, okay, if as before, we've had this kind of a picture of the collective IQ in here boosting, and I didn't go into that as deeply as I should have, I guess, because it's got to keep track of what's going on in the outside world. There's a lot of dialogue going on between it. We all know that that's important to capture. And this knowledge product here is sort of a new term that I just have been putting that in there for years. I used to call it the sort of electronic handbook for the community or something like that. That what you're going to need is, what is the current picture of the dynamically evolving knowledge that this particular community is needing to operate on and is collectively trying to improve. So it's not enough just to record all the dialogue and collect data and stuff like that. You have to keep integrating it into these knowledge products, so to speak. And it's I think it's more than knowledge management. It's much more than just having good retrieval or search capacities. That's all going to be done in there. It's really something special. We'll deal with that a little later. And so anyway, this is what that community would be doing. So we say, okay, that we call in our environment a NIC. And we says, okay, then we made up an alliance that says what we'd like to do is have a NIC whose members are NICs. And the whole purpose there is how do you to get them to, they work collectively at helping better and better to improve their capability to be a NIC. So that's the sense of our Bootstrap Alliance. And this is slowly beginning to get momentum here. And there's a very interesting thing that in Japan, they start organize some industrial, university, and government groups together to say, let's make a Japanese chapter of the Bootstrap Alliance and try this model of things in Japan. So all that emerged in the last year, and they picked this weekend, this Thursday and Friday, to do their big meeting, so I have to take off tomorrow to go to Japan, which I'd rather stay here and learn more talking with you guys. But so there are interesting potentials in this country too for this sort of thing growing. So that gives you the improvement community idea, and the bootstrapping idea comes pretty neatly about saying, if you're going to make a NIC like this, then one of the interesting things is how much of what the particular member B types are using is capabilities that they can know how to put into A to improve it. How much of that can come back in and improve the ability to be a NIC? So this is, we talk about, you know, that this is what we call a bootstrapping index. So first you'd like to go around, if you've got an alliance forming like that, and recruit NICs who have a high bootstrapping index. Oh, so that just accidentally happens to be somebody like CSCW team, or a number of the ACM SIGs. So we've been sort of quietly trying to recruit them. So we've got some semi-commitments out, and that we'd like to say, well, that's one thing here today, is saying, what does it take to turn this, you know, this CSCW thing into a real NIC? So some of the challenge is how, you know, if the world starts changing so it knows how to do this collective knowledge work better, the integration and management of the knowledge it's trying to generate and create so it comes back to do its members more good. Well, is your group going to be one of the leaders of that? It's sort of a natural. Well, anyway, it'd be very interesting to lay down the challenge of saying, what would it take to do that? So what we're trying to do is actually invite groups like that to start working with us to generate a plan to say, what would it take to do it? So some of the things you think about as well, that everything that goes on in the meeting ultimately is going to be recorded, which downstream is going to be that everybody you talk to is going to have a record of what you two talked about, or you five talked about. It's just going to be there. It's going to be all the capacity in the world for doing that. That anybody can go back later in any presentation like this, make a link to any given statement, passage, view that's got in there with highlighting what was shown to say, hey, this seems to be, it doesn't concur with something else. And just be part of, sorry about this, and just be part of the dynamic, real knowledge development dialogue that goes on. So you know that that's all very possible, and you've got to know that the technology is going to be emerging enough so it makes it doable. And so you also know that publishing your papers and the intense dialogue that could go on, that saying, well, what do we depend upon? Somebody writing textbooks every so often, and summaries? Well, the community is going to have to do it sometimes, so that knowledge product idea is equivalent for the textbook for your community, and it's something that is going to keep up to date, never be more than how far behind? A month behind? Well, in time won't be adequate for that. I'll be able to keep it up to within a week, because things are going to be happening so fast. And anyway, those are just, they're serious questions. I'm not. You guys have the capabilities to make that happen. I don't, but I can stand here and make you feel guilty by pointing at it. You can see what kind of a dad I was. So anyway, this bootstrapping thing comes in there. So we just summarized all that, and we've gotten activity, sort of participation by quite a group of people so far in the United States. And this is emerging, and there are some more things that are beginning to happen. And one of them is an emergence of saying, hey, you know, pursuing CoDIAK and OHS with an open source solution, which is very interesting. That this is the way that the Linux systems evolved, and several others are beginning to evolve. And it looks to me like about the only way that you can really move out to that frontier with tools and processes is get communities that are participating in the concurrent evolution of all the whole tool set. And so that the open source way of doing that means that anybody can keep contributing to new parts of it, and they can fit in certain ways. So we've gotten people that are in very key roles in standards groups, in having working with intelligent agents and working with object-oriented language standards, etc., with the XML extensions for the sort of the way in which the document structures can go. And we'll get a little more of this, but it's, so we're trying to build the participatory communities that would say, when we get out there and start working, damn. He says it's tea, it's probably some drug. So anyway, it's a not supposed to wipe your nose in public, I understand. What could I do? Anyway, this is beginning to emerge as something that's just very exciting, that getting people together to say, if we're going to explore that frontier, we can't wait for products to take us out there. We have to explore. And anyway, if we're going to have the kind of capabilities that we're going to need, we just have to do this. So we've got a whole set of functional tool capabilities that are sort of based in our history, et cetera, that are something to start. And I wanted to go back to here and talk about a few other things. This is one of my great inventions. In the 60s, I was trying to think of how do you get people to think that just the artifact for how you manipulate your symbols would make a big difference. So one day I did this, and I started giving it to people to say, write with it. So how do you think it would have changed our written language in our accounting systems, in our business practices, in our scholarship, if that was the best way we could connect ourselves to making external symbols? So it didn't take very long to get it across. There's another thing, it's this whole thing that's just plagued me terribly through that, is the assumption that what you're going to have in your tool system is something that's easy to learn and natural to use. And so you says, so it's sort of like saying, well, all the population and the farmers and everybody else that's going to start getting automobiles in the early 1900s, you got to make it that way. So you got to let them sit there and steer with these reins and things, your car, because it's got to be easy to learn. And if you think about how much you have to know and the kind of skills you have to have in order to operate a car in today's heavy traffic and freeways and merging, et cetera, like that, just notice sometimes and think about what would the people have said in 1905 if you tried to tell them that that's the way all this average Joe drivers will be calmly handling that sort of situation. And this really comes to me like that. Every time I merge, say 60, 65 miles an hour, and you're coming in there like that, you come in like that, and you usually take a look over your shoulder, get a quick size up of that like that. The rest of it you watch in your rearview mirror. And the 1905 guy would have said, you mean you're looking in that little mirror and you're judging how much does that car weigh, how fast is it going? My God, you're trying to judge whether it's going to notice you're there or not. Yeah, you just watch it. And you know all these instincts, and you get to lots of intersections, and just by looking, you just very quickly know who's a threat and who's going to give. So he says that kind of perceptual skill, coordinating skill, operating skill, what it takes to know how to buy a car, finance it, license it, maintain it, etc., and move around the geography. There's just a huge amount you've learned like that. So nobody back there would have been able to believe that we'd adjust that much. So that's the kind of thing. So it's like the computer people that keep with the, I mean, I a lot of times get credited, but I keep thinking debited with, the GUI, the modern GUI. And I didn't like it. I set aside the menu picking way back because we learned how to use things with this left-hand keystroke. And by the time you can go click on a menu item, you could hit 4, 5, 6 characters here. And never was it worth that much information. And besides, if you use the key set You can be saying what you want to do before you get the cursor where you want to go. So not only say what verb you want to action, but you can also say the class of noun you want. So you can click any place in that particular object class, and bingo, you've selected the whole thing. Very much faster, very much more efficient. And yet, it's when you look at what people have to learn today with a GUI, you say, hey, that's not easy. So anyway, that's what I pictured. This is the GUI. You can get on it and start writing right away. And this is the one that's going to come about someday. That, yes, everybody will learn it, and it'll be much, much more efficient. So that's the kind of thing. So talking about in the role of what your open hyperdocument system is going to need. So when I was McDonnell Douglas, I got educated with things like this. Look at all the divisions and things that have to work together. They have to actually work together and communicate. So that's pretty good. That's impressive. It says, okay, they can't all be using the same applications, et cetera, like that. But what they need to have is the same way in which the data structures, et cetera, are there. So that has to be an open sort of environment. And the other thing that they showed me, which was just overwhelming, so we build a fighter plane. So maybe 2,000 or 3,000 people inside working on the design of this thing and manufacture. But look, first-tier suppliers that are actively involved in designing things like the landing gear, et cetera. Lots of interaction with them. Less interaction with all these others, but every time we get a delivery from them, the test material has to come with it, be tied in and integrated. And you know, this is all some kind of comprehensive knowledge environment. The specifications that are being involved are something that ought to be standard and linkable to. So we just made a picture about how you could do that with a really effective open hyperdocument, which we had a good model in the Augment environment that was there. I'm trying to say how much would that save. So anyway, then we could make a picture too of the kind of basic collaborative knowledge work. And the way we started out there was says no, not just shared files, that they want to be structured, because one of the new things out there, the computer can handle structure that's explicitly connected with the structuring that you do implicitly or explicitly in the way the concepts in your mind are related and structured, and the syntax of a sentence is an example, and of arguments, etc. So we put explicit hierarchical structure just to start and assumed that that would get matured beyond that. And every object is just linkable from the start. Every object just totally addressable right from the start. And integrated editor browser. We would have just laughed ourselves silly at the idea of having two separate ones like that. So the open hyperdocument thing we're trying to move to is say you start with HTML and XML extending it, but you integrate your editing and you're moving all your functions into the concurrently with the browser. It just only makes sense. So there was a great deal here that went on. Our email was hyper objects, so you could interlink between any passages of any email as well as anything in your files. And a very important thing we added was something in which you could submit a document or something to the journal, and it was like published. Got cataloged in the journal, got held, that all you need to do to make a link hit, the URL equivalent, was just the name of the journal and the identifier was given to that document. And if you were a bona fide paying member of that journal, when you clicked and went there, what you were given was guaranteed to be that which was written and published in that particular moment in time. And this made such a difference in the dialogue where you were linking to things and you didn't have to worry about that you knew what you were linking to and pointing at was a passage that would be there for subsequent readers of what you were writing. So it made a much more compact way to carry on the dialogue. So many, many things like that were evolving. And another big thing that we did by 1974, and we were out there supporting customers at the time, and everybody, any place in there could call up somebody and link. And your screen would be showing, this guy's screen would get cut from his own application and get tied to this one, and just tied with a link. Worked a while, then you can say, well, pass me the controls and I'll show you. So he goes through a little bit of protocol, and this guy now is in control. So we could do that with up to 6 or 7 people around the country at a time. And we published it, assumed that everybody would be doing that. And that really has to be that general. And you also have to get situations where you can connect with CAD systems and other heavy database like that. So I'm going to go back. So anyway, this open source pursuit is a very important thing for us to do. And another important thing is that the only way you're going to get out in that frontier is to get high performance teams that are really break away from from what everybody, the way you can do it, and just really go all out in training, recruiting, equipment. No limit to the unusual ways in which their fundamental sensory, perceptual, cognitive, motor capabilities are trained, conditioned, and harnessed. And so it just, thinking about this over the years, it lines up to saying, I guess they should be support teams. And this solves another very critical problem, is that that they have to be pushing on the frontier to learn how to do heavy knowledge work much more effectively. But if they're all by themselves, how do you get any transfer of knowledge or experience? So the best thing for them to be doing is to support a larger, conventionally capable community. And really the big thing is to facilitate the CoDIAK processes, maintaining and associated with developing and maintaining the dynamic knowledge repository for that larger community. And there, this is okay. The integration one is the really challenge, et cetera, like that. So you could get teams that are really focused on that. And this is one of the reasons why, through all the years, we've been saying that you have to have multi-class user interface provided in your functional tool systems operating on your standard document structures, so that you can just get high-performance support teams to work in there, and they can go flying around, and that they can be depending upon properties and tags and underneath there that the pedestrian users don't even know about, don't have to know. And a user can start moving himself or herself up in grades of capability inside that environment. And if the very highest performance teams are really doing that core integration, that they're really involved in a lot that they can do to come on with that shared screen support, and really people can watch and just sort of get the experience. So something like that has to happen if we're going to be able to evolve in the kind of large-scale social way that's necessary into the frontier that's out there. So anyway, this is the sort of pursuit, and I need to start tapering down. So high-performance support teams inside a university environment, one of the really interesting things is like, hey, high-performance scholarship is almost a term for it. And so if they belong to some research community like that, that this is sort of the way in which the textbook or handbook of that keeps getting integrated. So how soon? Anyway, these are for real. Who's going to help most to get there? So one of the real challenges is in here that these were all important things and steps you can take, and one of them is, hey, what's the possibility for a NIC of selected ACM SIGs out there working? So that's what I'd like to see, and I really like, we've in communicating with SIG-Chi and SIG-Link, and so we'd be really like to get some of the others in there and potentially go together to apply to in National Science Foundation's Knowledge and Distributed Intelligence program next February, to say, hey, get some funds to help these NIC, an ACM NIC come together. And I think I've been starting to talk to Barbara Simon and see how that goes. So here we are, and got to end on a splash. So there you guys sit in your future environment. How do you like that? Is there still time for questions?
Yeah, we'll do a few questions. Do you want to,
You want to make an old man cry?
we do have time for a few questions. If there's some mics in the aisles, and feel free.
Anyway, my name is Bill Ladinsky. I'm from Fermi National Accelerator Laboratory. The microphone doesn't seem to be working. Okay. One of the things you didn't mention, which I have mixed emotions and feelings about, but which is probably in our future, is the fact that human cloning is probably going to show up. And with the possibility and the terror that that might bring, but what it might bring is improved capabilities of one sort or another. I'm afraid Pandora's box is open on that one. Have you thought about that at all in terms of the sorts of things we're talking about in the future? I realize this is very, very, sort of 250,000-foot level stuff, but some of what you talked about was at that level.
Yeah. Well, what I do with things like that is put them over there and say, those are real challenges because they can be intriguing and they can be frightfully dangerous. And I think we have to have smarter society in order to be able to handle it. So there are quite a few things like that. I think that our economic structures are, when things are happening so rapidly and dynamically, probably aren't stable enough, and et cetera. You can make horrible stories about the environment that we're doing to that. We just have to get collectively smarter. Whether we'll get collectively saner is another question. And, I don't know how long it'll take for people to implement those things, and all I know is that that in my image, if we don't, I don't think we're going to make it. So it's very important, and that's what keeps me going. So, I guess I'm an optimist. At least it's saying that there's terrific potential for human race, and it'd be too bad if we all collapsed without trying to get to that potential. And
Thank you very much for your inspiration. We'll just have to keep it up.
yep.
Doug, Austin Henderson, thank you very much for the work you've done and for this presentation. I have Austin Henderson. Doug, thank you very much for the presentation and for the work you've done. I have one question about the goal of these groups working together. Do you think success of coming to a collective understanding is taking different perspectives and arriving at a single smarts, a single view, or is it more that one tries to somehow or other maintain a whole collection of views working together?
Yeah, I'm very leery of operating with one view, even if it's just mine. And so in looking at the kind of infrastructure that would be best, it sort of is that there ought to be a lot of outposts out there trying, but it also ought to be that there's open exchange to find out which are working better for us all to do. And so that's the picture I have. That in this open hyperdocument system, we have a lot of things we learned that were very high payoffs in the augment world that'd be nice to install in it early, but then have it open, and quite a set of communities of different people putting it to different work, but still appreciating that underlying it has to have a open standard for the document pattern. And there are things, for instance, in ours that when you open a window and had a document objects in there, that window belonged to that document, and you could bring in any one of a number of tools to operate on it. That's this kind of thing there, so that you could we had evolution of a lot of interesting things going into that. So building an environment that really opens up evolution is very important. And the marketplace isn't built for that kind of evolution in that much of a frontier. It's very, very good if the consumers know pretty much what they want. Like any of you that knows about trying to find optimum points in a multidimensional environment, that you know that your optimizing program often could get on what they call a local maximum. It's like it finds a hill and gets to the top of it, but over there 10 miles is a much bigger hill that it didn't find. So the marketplace is very good for climbing a hill if you're on the right hill. But what we do have to find a lot more exploration, and it's not good for finding those hills.
Thank you.
Again, I'd like to thank Doug Engelbart.
Should I just send everything out?
Sorry?
Should I take this down?
We've been waiting for it. Just one brief announcement. I'm going to ask you to leave this ballroom very quickly so that the hotel staff can divide it up into 2 rooms. Thanks again.